Welcome back once again, everybody. I'm Don Seifrit. It's the Dr. Treefert and Don podcast. This is our post-harvest rot series. I'm here with Dr. Kari Peter. Say hi, Kari.
Hello.
Here with Dr. Wayne Jurick once again. Say hi, Wayne.
Hello.
And for the first time, we have Dr. Dianiris Luciano-Rosario.
Hello.
How'd I do? Well?
Yes.
All right, cool, great. I wanted to make sure. So Dianiris is here to talk about her research today. Correct me if I'm wrong, but you do a lot of work on bin sanitation.
Yes, correct. I started a project recently on bin sanitation, which is often overlooked in the apple and blue mold industry and post-harvest rots. Yes.
Cool.
And when did you started working for Wayne Jurick? When did you start working for Wayne?
I started working as a postdoc for Wayne Jurick on September 2022. I've been here about 5 or 6 months already.
Nice. Well, before we get too much into your work, why don't you tell us a little bit about yourself, your background, how you got interested in plant pathology, that sort of thing.
Okay, sounds good. So I'm originally from Puerto Rico, which is a tropical island in the Caribbean. And I grew up there. I did my bachelor's degree in biology, general biology there. And while pursuing that, I entered a tropical agriculture lab. And we did molecular biology, and I got interested in plants. Then I went to an internship. An REU, for those who don't know, is an NSF-funded summer internship where I discovered plant pathology in a bacterial spec laboratory. And then after that, I wanted to pursue a master's and then a PhD. And I did that in Puerto Rico, where I studied papaya, not plant pathology there, but for the PhD, I wanted to study plant diseases. So I studied blue mold disease in a fungal biology lab. And then I just love diseases and how the plants and microbes interact. So yeah, that's my background.
Cool. So not a whole lot of papayas up here in Pennsylvania where we're recording, and not very many in DC either, but we're glad that you're here working on blue mold. Tell us, since I kind of jumped over your research there, why don't we go back and talk about the current work that you are doing on the bins?
We know that blue mold is a problem in packing houses as a post-harvest disease of apples and pears, but really there are many studies focusing on which are the inoculum sources for this pathogen and how to reduce disease incidence of blue mold. So one of the focuses that Wayne, Kari, and others has investigated is the possibility that beans are an important source of inoculum for blue mold disease. So in a recent study, they tested different materials, bean materials, and how these can foster the blue mold spores in them. And they found that plastic harbors fewer spores than wooden beans, and then that you can apply some fungicides or some treatments to reduce that spore inoculum. There are still questions that are unanswered, as is, we know that the spores are there, but we don't know if these are a significant source of disease-causing inoculum. So we're trying to investigate how these spores that are already on the bean can transfer or not to apples and how these serve as inoculum sources. Along those lines, we also want to develop more techniques to sanitize beans, which is often not practiced here in the Mid-Atlantic area. So that's the summary of what the questions that I'm trying to answer.
Cool. A question that I had as you were talking about that is, how do you sample bins for spores? Are you like going out there with a swab and like digging it up into every little crevice that's in a wooden bin? Because I've seen some that are in really bad shape, and there's a lot of places that you would have to swab, but the plastic ones are usually in a lot better shape.
People have done this in different places. So in the past, some other groups have swabbed different areas from the bean and then collect spores that way and then put it in water and then count in plates. They grow the fungus in a petri plate and then count those spores and then calculate how many spores are per area in the bin. But this recent study that I referenced earlier did a very interesting methodology in which they control the whole situation. So they first clean up beans and then sterilize them, no spores there. And then they, in a controlled manner, inoculated those beans with spores. So the beans had spores. And then what they did is treated with the treatment that they wanted to test. One of them was steam or hot water as a treatment to reduce spore inoculum. The other was academy, the fungicide, and time guard, which is one of the new generation bactericides and biocides, right? So then after that, after those treatments, they soak these beans for 3 minutes in water and then sample that water and calculated how many spores they recovered, this from before and then from after on that water. And they found that any treatment is better than no treatment. And there's a difference for wood and plastic. So for wood being a steam sterilization better than the fungicide, for plastic, the fungicides perform better.
That's really interesting. Yeah, I was super curious because I think for a lot of folks, you know, if you talk about bin sanitation, they start going, man, I got a lot of bins. How am I going to do this in any way that's timely or economically reasonable? So yeah, I super appreciate the clarification there.
Yeah, and it's expensive. Like, I mean, as you said, there's an expense with it. And one thing just to note for the listeners, Academy, this is a fungicide that people may not be familiar with. It's a newer one from the last few years, but there's 2 chemicals in Academy, difenoconazole and fludeoxonil, correct? Yeah, I think that's what it was. Where all the other ones that we talked about prior, it's just one chemical.
Correct. And the idea of trying different treatments is that we know there are different operation sizes in this area. So we want to cast a wide net on learning about like different treatments. So any size of packing house can adjust their practices to what we find and reduce that spore inoculum.
Yeah, that's really important because you know, with Johanni's work, what we have found is there really won't be a one size fits all approach for the Mid-Atlantic because there are so many different size operations, which is in contrast to the West Coast, where it seems that everyone's pretty much big and there is a one size pretty much fits all approach. So I think it's really great to come up with options depending on what your size is. So it's more accessible regardless of how much you pack. So, and that there are options out there. So I think that's really awesome.
Right.
So, and forgive me if this seems silly, but in that work that you're describing where folks were sampling these bins for spores, did they find that there were more spores in certain areas of bins? Like if I have all my bins outside sitting on a patio, right, or on a big concrete pad, are there more spores underneath? Are there more spores on top, like on the interior? If that's way out of left field, let me know. But I didn't know if that was something that folks were looking at.
No, okay. So for this study, they didn't focus on which area had more spores than other, but in other studies, other scientists have focused on that, and they found that the outside of the bin usually is where more blue mold spores are. That doesn't mean that there aren't any spores in the other areas, especially if there is plant debris that is left over or other leftover material from previous season or from a previous process that was done in those bins. So it's very important also to clean that debris that can also act as a source of inoculum. Yeah, from what we know from previous studies, the outside of the bin should be the one that has more spores.
Okay, cool. Yeah, because I wasn't sure, you know, if maybe folks started putting their bins on a set of pallets, you know, raise it up off the ground, or if they need to cover them with a tarp over top. But if it's the outside, you know, those are just kind of what's exposed to the air constantly. So that makes sense.
Right.
Can you explain to us kind of how these spores contribute to decay?
Okay, yeah, so blue mold is a filamentous fungal species, and its main inoculum source is conidia, which are asexual spores, and these are produced as the fungus grows on the plant material, on apple fruits, or in plant debris. It lives as a saprophyte, so it's not as a pathogen. Spores enter a wounded apple or a wounded plant material. It then infects, grows, and sporulates more, creating more inoculum. And we already know from Johanni's work that there are Penicillium expansum spores in the air, in the water, and all of these are reservoir and potential inoculum source for causing disease in apples. We know that the beans are not the only possible inoculum source, but we want to reduce or try to reduce as much as possible in all of the aspects, this being the one that I'm focusing on right now.
Sure, makes sense. I mean, we're going to put our apples into these bins. We might as well have them not contributing to the negative condition of our fruit. Yeah, that makes a ton of sense. You kind of touched on this a little bit when you talked about different treatments that folks were looking at. So let's say I'm all on board with sterilizing my bins. What are the treatments available to me, and how would I go about kind of moving that forward? Like, do I have to change a bunch of things? Do I need to install a bunch of things? What is kind of my process for going forward with this?
Okay, so the treatments that are available right now that we have tested are steam sterilization for wooden boards and hot water for plastic bins, apart from fungicide dippings. In other facilities, people have used sodium hypochlorite, which is Clorox. We have not tested that treatment here, but I know it's used in other facilities. But for now, there are equipment there is an equipment for steam sterilization. It's not widely used here because of the energy and energetic cost, and we are looking at trying other type of sterilization, for example, using UV as a possibility to sterilize these beans. We showed that dipping the beans in fungicide works. I don't know if it's the most cost effective at the moment. We still don't know if this is the most important inoculum source. So for now, it's an ongoing investigation, but data suggests that treating it with hot water or steaming reduces the inoculum source from beans.
I know one question people may ask: if people opt for dipping in fungicides, the risk of developing fungicide resistance to whatever could be there. Would people be encouraged to rotate fungicides that they would be dipping the bins in? I mean, because you recommend that when you're treating fruit with fungicides, is that what we would be recommending for bins? And is it on the label? Then there's like the whole label issue with permission with regards to being able to use fungicides in that way. Like, there's a few questions I got there: fungicide resistance and the legality of it.
So for fungicide resistance, yes, always switch mode of actions. That's pretty standard in all of the fungicide programs. I'm not sure about the legality of it or how it is recommended.
I can pipe in there for a second. I think you're going down the right path. So the applicability of the fungicide treatment was for growers or for large scale producers that use a bin dumping system. So it wouldn't necessarily be that they'd be dumping their bins in there, but that they would incorporate a fungicide at the labeled rate into the water that's used to grade the fruit. So the study was designed so that the bins would our study mimicked what happens with a bin dumper. So the application here for the option for producers would be to add the fungicide or the thyme guard to the grading sizing water. So I think that helps with the question of labeled rates, legality. The labeled rate's an easy question for Academy because there's only one. It's 16 fluid ounces per 100 gallon. People are using bin scrubbers and bin steamers, but as Dianiris alluded to, the efficacy of these things hasn't been scientifically evaluated, and the energy costs are the main reason for industry not widely adopting them. So we did this research, Kari, Jurick, and I, and Dianiris, we all did this research with the aim of trying to provide some answers in short term, which I think we have, but then also long term, our goal is to develop a quick way to sanitize these bins that's good for return on investment, but also proving that the spores on the bins, whether in or outside the bin surface, can facilitate rot. And so that's where we need to go next. And we haven't gotten there yet, but we're working towards that. And but I think we've made a pretty significant level of progress with this so far, but we've got a ways to go yet.
Okay, good. Thanks. Yeah. I'm just thinking as far as for the listener, as far as how they're visualizing things. So thanks for adding more clarification.
I've got one more question, and this again might be super out of the wheelhouse. People can buy like fungicidal anti-mold paints for their home, right? Primer and that sort of thing. Is anyone looking at painting bins? Now, I know it would be a huge pain in the butt and probably more work than steam sterilization or dipping. Something that I guess potentially could work multiple seasons. Is anyone looking at that?
We are not looking at that, but you just gave us an idea, and I think it's worth evaluating and considering it. Now that we also have that technology. So the answer is no, we're not looking at it, but now there's another idea to maybe try.
I could see that for the salvaging the wooden bins and using like a high, as far as a high pressure painter, like what they use on houses. It's something that I think could easily be achieved. Not just a paint roller, but actually, more of a industrial type painting mechanism. Yeah, I think that would be interesting. Ooh, Wayne, I smell another research proposal.
Yeah. I think the other thing too that we're considering, and it's again it's in the pipeline of ideas, is along your lines of treating the bins with paint, but we were thinking more nano encapsulated materials, so nanotechnologies. So just treating the bins with a nanotech compound that was either fungistatic, fungicidal, or would stop the sticking, because the spores are very sticky chemically, if you want to say, from a chemical perspective. So if we can change the binding capacity of the spores and make them not stick, kind of like wax on your car, something you apply to the bin. So a nano material that you'd apply so that things don't stick, then voila, you don't have to worry about it. That's an option that we're working with. We're going to work with our research leader, Jorge Fonseca, on a project he's doing with Blueberry, but then also nanobubbles. There's a group doing work with nanobubbles as well. So we have a lot of different ideas, options, and plans of attack for this. So it just takes a while to put these things in motion and work them out systematically. And of course, mimicking the storage conditions that are as close to commercial storage as possible. So low temperature, but then over extended periods of time. So these studies are, while they're relatively straightforward, they're a little bit more demanding from a time standpoint to be able to get the data and then repeat everything. So, but these are all good ideas and things that we plan to investigate, and I think will lead to answers and multiple options for producers of different scales.
Thanks. The nice thing about not being a pathologist, and I make this joke a lot, is that you don't know if the question you're asking is absolutely insane. And then you get some people who are a lot smarter than you to answer that question. So
don't sell yourself short, Don. That was a great question.
From these ideas flourished, so that was great.
Thanks. I appreciate it. My wife and I bought a house within the last year, and it's all of these things that are now at the forefront of our minds when it comes to home ownership. I was like, wait a second, could we just paint things? It also came up when folks were talking about rail cars and spotted lanternfly and moving rail cars between state to state, talking about potentially using like insecticidal paints on rail cars. So I was like, well, maybe that's an option for fungi. I don't know.
Creosote. The other thing I'll add into this too is I just want to make sure that we address the historical foundational work that's been done. I mean, we're not the first people that have worked on this bin issue. A lot of the pioneering work on this came out of the West Coast, which is a different type of production system, different environment. But there's also been some work by Dave Rosenberger in New York to do some of these tests. But the bulk of it was Washington State and Oregon, where they looked at, bins being sources of inoculum, steam treatments. And I just want to make the statement that the steam for the wooden and the plastic bins, they showed it not only knocked the spore levels back for penicillium or the blue mold fungus, but it also helped with coddling moth. So it was an insect issue, which we're not looking at, but we'd be happy to partner up with an entomologist if they wanted to look at some of these things. We're not bug folks. But, you could envision that some of these things may overlap. So anyway, I just wanted to make sure that the history of bin sanitation with Kupferman, Changling Chow, Bob Spots, all these pioneers out in the West Coast that kind of started this work. Peter Schulberg in Canada, going back almost 20, 25 years. But we needed more regional specific data because our production system's different. and our practices are a little bit different. So we figured we'd pick this back up and we'd address this. And these are the things that industry wants us to investigate. We're doing this at the request of industry in partnership, Kari and I, and Carrot Cox at Cornell. We're doing this because we were asked to work on this. I just want to make sure we go over the historical perspective of some of this research that we built upon.
Just to sort of add a few more details of the regional specific, in Pennsylvania and Adams County, we do have the largest pack house on the East Coast rice fruit company. There are ones that are, not quite as big, but forced unto themselves. And then we've got, medium-sized ones and smaller ones, and I think it's important to really just to hammer home the importance of regional specific data. Just because what works in one area of the country doesn't mean that it's going to be working the same on another side of the country. So, and the other thing is that these folks want to see like, okay, what works in the West Coast, does it really work for us? And just because it works for them doesn't always mean that they're going to have the same cost benefit experience.
So, Dianiris, I think we do a lot of these interviews with folks and they do these jobs, any of the folks on here have a job that you only do because you find it really fulfilling and you enjoy your job. You look forward to coming into work every day. So for you, what is the most fulfilling part about your position?
I think the possibility of always answering a question. In the past, I've mostly done basic research. In this applied stuff, the possibility of having an impact on someone's production system or on someone's facility. So both curiosity, like fulfilling that personal side, and also being the possibility of impacting growers and people that are in agriculture.
Nice. So what is like your long-term projection for this position or for this research?
So for this research, hopefully we come up with some guides on how to properly sanitize beans and showing that these are possibly important as a source of inoculum. So contributing to that, reducing inoculum at different parts of the disease cycle, which plant pathologies we like to focus on. So just adding that little bit of knowledge or impact to having a healthier or less disease environment and leading to less food waste and leading to fewer economic losses from packing houses and from the whole apple industry.
All right. Well, thank you so much, Dianiris, for being on here this morning with us and answering all these questions, some of my very outlandish left field questions, and super appreciate your time. And Wayne, thanks again for joining us. Kari and I are always on here, so I don't know.
It's been great. I've been really enjoying this series that we're doing on post-harvest because, again, it's near and dear to my heart because this is where I cut my teeth on tree fruit was with post-harvest with Wayne. And I always say, and I know this is a groan, I have a soft spot for rots. So,
Nice.
Yeah, thank you.
Such a corny joke.
Yeah, I know.
Thank you, Donna and Kari, for having me and inviting me to the podcast, and Wayne for having me at the lab as well.
Yeah, thank you for joining us. Yeah, this was awesome.
Anytime you want to come back, you're absolutely more than welcome.
I'll be happy to.
Awesome.
Thank you.
So, all right, say goodbye, everybody.
Goodbye.
Bye.
Bye.